So for number 1, if 3x minus y equals 12, what is the value of 8 to the power of x divided by 2 to the power of y? The first step for this problem is to solve for y, and we're going to do that by first subtracting 3x from both sides. And remember that numbers and variables cannot be combined, so 12 minus 3x, you can't simplify that to 9. You leave it as 12 minus 3x. Don't forget y has a negative in front of it. To cancel that out, we're going to need to divide all three numbers by a negative 1. And we get y is equal to negative 12 plus 3x. The next thing we do is we substitute for y. It used to say 8 to the power of x divided by 2 to the power of y. And we're going to replace y with what it's equal to. Notice the only change I made is instead of writing it as negative 12 plus 3x, I wrote it as 3x minus 12. I just switched the order. It's still the same thing. We'd like to use this formula below. X to the power of a divided by x to the power of b is equal to x to the power of a minus b. But the problem is that we need to have the same base. And we have a base of 8 on the top of this fraction and a base of 2 on the bottom. If we recognize that 8 is the same thing as 2 to the power of 3, we can replace and have the same base. This will allow us to use this formula. When we do that, it looks like this. 8 to the power of x becomes 2 to the power of 3x. On the bottom, we have 2 to the power of 3x minus 12 still. If we subtract the 2, 3x minus 3x is gone, and minus a negative 12 is a positive 12. So our final answer is 2 to the 12th. For the second one, we start with the same formula. X to the power of a divided by x to the power of b is equal to x to the power of a minus b. And when we apply this to this problem, we end up with x to the a squared minus b squared, which is equal to x to the 16th. A squared, which is on top, goes right here, and b squared, which is on bottom, is subtracted. From this, we know that a squared minus b squared, it must be equal to 16. This we can use the difference in squares formula. And it turns out to be a plus b times a minus b is equal to 16. They tell us elsewhere in the problem that a plus b is equal to 2. So we can replace that. When we divide both sides by 2, we find out that a minus b is equal to 8. We don't need to solve for anything else. We already have our answer. So on the back, number 3 for the exponentials, we're looking at the exponential growth or decay formula, which says this: a function of time is your principal or initial amount multiplied by the rate to the power of the number of time, or years, the number of years. Here we're looking at a principal amount of 325 grams, and this occurs over t years. So we have to figure out, is this growth or is this decay? And it turns out it's decay. So we take 100 minus 13, and we get 87. We'll move the decimal place over twice, and our rate turns out to be 0.87, which is letter A. Down here at the bottom, we see that if a to the power of b divided by 4 equals 16, for positive integers a and b, what is one possible value of b? There's not a multiple choice question, it's fill in the blank, and there's more than one right answer. In fact, here is every possible answer. Because that exponent has b divided by 4, we can plug in numbers like 4, which will give us an exponent of 1, 16 to the first power. We can plug in larger numbers like 8 or 16, which will give us exponents of 2 or 4, and with the right base, that'll give us 16. Or we can make the exponent a fraction. 2 over 4 makes 256 raised to the 1/2 power, which is kind of like taking the square root of 256. And this last one is like taking the fourth root of 65,536. All of these equal 16. We don't care about the a values, we want the b values. So your possible answers are 4, 8, 16, 2, or 1. As long as you had one of them, it's right.